Would you like to be able to pick up objects, move them around, rotate, and throw them in your game using a physics-based grab interaction system? Well, in this video, I'll show you how to do exactly that using the PhysX Grab gem in O3DE. This is a third-party gem developed by us, and it's completely free to use and open source. This gem also offers advanced features you don't often see, like offset grabbing for realistic object tilting, ability to charge up throws using variable strength, and even a PID controller that can create bouncy, spring-like motion when moving objects. You can make heavy objects harder to pick up for added realism, or keep everything feeling uniform regardless of mass. Let's start by setting up the gem in O3DE. First, make sure you have both O3DE and Git installed. Next, download the PhysX Grab gem. The repository is hosted on GitHub, and you can find the link in the description. On the repository's page, click the code button and copy the URL. You'll need it in a moment. Now open O3DE's Project Manager. Click the Gems tab at the top. In the top right corner, click the hamburger menu icon, select Show Gem Repos, and click Add Repository. Here is where you will paste that GitHub link we copied earlier. Then click the Add button. After adding the PhysX Grab gem, we need to enable it in a project. In this video, we'll add it to an existing project. Click the back arrow and then go back to the Projects tab in the Project Manager. Click the menu icon underneath your project and select Configure Gems. You'll see a new page with a bunch of gems in O3DE. Let's do a search for the PhysX Grab gem. Then you need to toggle this on to enable the gem. Then click Save. You might see a pop-up message telling you that the gem requires the PhysX 5 starting point input and Lumber Central gems. You want to make sure that these gems are installed with your project. You also want to make sure that only the PhysX 5 gem is activated and not PhysX 4. Click Continue, and then you'll get a message saying that your project likely needs to be rebuilt. Click OK. Now we need to build our project. Click the Build Project button, then click Build Now. Then select Yes. After the project finishes building, click Open Editor. I'm going to select an existing level for this, but you can create a new level if you'd like. Once you're in the editor, you'll want to decide which entity will use the PhysX Grab component. This gem was mainly designed to be used with a first-person controller and camera. It is possible to use it in third person, but we recommend using it in first person because it relies on camera rotations to interact with objects. I already have a player character entity set up with the first person controller component, as well as a camera entity that's a child of the player character. If you want to set this up for yourself, check out the first person controller gem video. Or if you already have your own controller, feel free to use that. Now let's add the component to this entity. Search for the PhysX Grab component. When you first add it, you might get a warning telling you that you're missing required components. Let's click Add Required Component and select the Input component. Now you should see the PhysX Grab component and the Input component on your player character. On the PhysX Grab component, click the down arrow icon next to Input Bindings. We're going to map these to our input event names in the asset editor so we can grab, throw, and rotate objects. So let's go over to the asset editor. If you don't see it, go over to Tools and click Asset Editor. I'm going to open an existing input binding file I already created. Click this plus icon in the input event groups. Let's start with the grab key. This will be the input to pick up objects. For the event name, you want to enter the same name we have for the grab key in the PhysX Grab component. The default name is grab, so I'll type that in here. This can be any name. You just have to make sure it matches the corresponding input binding field in the PhysX Grab component. Next, you want to click the plus icon here next to Event Generators. A small window will pop up. Make sure it's at Input Event Map, then click OK. Now click this little arrow icon. And then click this drop-down menu next to Input Device Type. I'm going to select mouse, but you can use whichever device you prefer. Next to the input name is where we'll select the type of mouse input we want to use for grabbing. This is mouse button left by default, which is the left mouse click. You can choose whichever you prefer. Now the grab key binding is set up. I'm going to skip ahead for the rest of the key bindings like rotate and throw, but you can pause the video here and copy these settings. With all of our key bindings set up, let's save this input binding file by going to File and Save. Now if we go back to our player character entity and go to the input component, we can assign our new input binding by clicking this icon. Then save the project. Now it's time to test the grab key. Let's enter game mode by pressing Ctrl and G. Wait a minute. We don't have any objects in our level to actually grab anything. We might want to set those up first. Exit game mode by pressing the Escape key. Let's create a new entity called PhysX Box. This will be our grabbable object. Next, let's add a mesh component to this entity so we can actually see it. Search for mesh and add the mesh component. In the model asset field, click the folder icon, search for box, and then select the box 1x1 FBX file. Now let's move the box in front of our character so we can actually see it during game mode. Go up to the transform component and next to translate, type in 3 meters for Y and 0.5 meters for Z. Next, we need to add a rigid body component and collider to enable physics interactions. Click on Add Component and search for rigid body. We want the PhysX dynamic rigid body because these are fully simulated by the physics engine and react to forces like gravity, collisions, and impulses. Static rigid bodies are typically unmovable and are not affected by forces like gravity and collisions. Once we add the PhysX dynamic rigid body, take a look at the Type field. This field determines whether the rigid body is simulated, also called dynamic, or kinematic. The PhysX grab component works with both simulated and kinematic rigid bodies, but I'm going to keep it at simulated because we want it to act like a real movable object. Now we need to add a collider to our box to enable physics collisions, and so the PhysX grab component can properly detect this object and let us pick it up. Click Add Component and search for collider. We'll use the PhysX primitive collider because we're using a simple primitive box mesh. Great, now we have the components we need to start grabbing. Let's save the project. If we enter game mode and click on the object, you'll notice we can't pick it up. This is because we haven't set up our collision layers and groups yet. The PhysX grab component uses collision filtering to detect grabbable objects. This way you can specify which objects you want to enable grabbing for in your game. So let's set up our collision filtering. We'll need to use the PhysX configuration tool for this. You can find it in Tools and then select PhysX configuration. Now let's go to the Collision Filtering tab. I'm going to create 4 new collision layers: Grabbable Object Layer, Temp Layer, Player Character Layer, and Ground Layer. Next, let's set up the collision groups. Click the Groups button. We'll create a Grabbable Objects group and a Player Character group. For the Grabbable Objects group, uncheck everything except Grabbable Object Layer and Temp Layer. For the Player Character group, uncheck everything but the Grabbable Objects layer and Ground. Now we're finished setting up the collision layers and groups. Let's go back to our PhysX box entity and over to the collider component. Click the drop-down menu next to Collision Layer and select Grabbable Object Layer. Then click the drop-down menu for Collides With and select All. Now let's go back to the PhysX grab component on the player character and drop down the detection parameters. Next to Sphere Cast Collision Group, we want to select the Grabbable Object Group. This will make sure that the PhysX grab component will only detect objects in the Grabbable Objects group. And then next to Temp Grabbed Object Collision Layer, select Temp Layer. After this, scroll to our character entity's PhysX Character Controller component. For the collision layer, select Player Character Layer. And for Collides With, select All. And if you're using the first-person controller component in the jumping section, set the grounded collision group to the player character group. Also, make sure your ground entity collision layer is also set to ground layer. There's one more thing we need to do. Go back to the PhysX grab component on the player character entity, then go over to Hold Parameters and click the drop-down arrow. We'll need to set the grab entity. This tells the grab component which entity will perform the grabbing. For a first-person game, this will typically be the player camera, because that keeps the object in view of the camera when it's rotated. So I'm going to select my player character's camera. Now that collision filtering is fully set up, we can finally grab our PhysX box. If you enter game mode and press and hold the grab key, you should be able to pick up the box and move it around. Releasing the grab key will drop the object by default. You can also rotate the object, change the grab distance, and even throw it. Now, some of you might notice the object stuttering a bit as you move it around. If you'd like to learn how to fix that and also fully customize the PhysX Grab component to enable features like offset grab, chargeable throw, grab toggle, or adjust the rotation sensitivity, then stick around so we can learn about each parameter and what they do. The input bindings group is where you can specify the string names for the input bindings, which we looked at before. Let's take a look at detection parameters. The PhysX Grab component uses a sphere cast to detect grabbable objects. The sphere cast is projected in the forward direction of the grabbing entity, in our case the player camera. If the sphere cast collides with an object that is in our grabbable objects collision group, then this object can be picked up. The sphere cast radius determines the size of the radius you want for the object detection. A bigger radius means a larger grab area. Sphere cast distance is how far you want to be able to detect objects. The sphere cast collision group is the collision group you want to use to detect grabbable objects. The temp grab object collision layer is the collision layer that the object switches to while the object is being held. The reason for this temporary layer is to prevent things like jumping on held objects, which will basically let your character fly and might break the game. Detect in idle allows you to perform the sphere cast in the idle state. This lets you check for grabbable objects before pressing the grab key. Now let's go to hold parameters. The grab entity is what does the grabbing. If you leave this blank, it'll default to the active camera. If you have the first-person controller gem enabled for your project, then you will see this parameter. Use first-person controller for grab. We recommend turning this on if you're using the first-person controller component. It'll enable more responsive object tracking, but it's not required. Now, if you see object stuttering, we'll address that here. Mesh smoothing reduces jitter caused by mismatch between the PhysX time step and frame rate. If your fixed time step is slower than your FPS and you try to move your object around, you might notice the object stutter and snap to locations. Enabling mesh smoothing will help reduce this stuttering. However, for this to work properly, we need to move our object's mesh component to a new child entity. So let's do that. Right-click the PhysX box entity and select Create Entity. Let's name this entity Box Mesh. Now let's go back to our parent PhysX box entity, right-click Mesh Component, and select Cut Component. Then go back to the Box Mesh child entity, right-click, and select Paste Component. After this, you might need to reset the transform values of the Box Mesh entity. Okay, just one more thing we need to do to set up mesh smoothing. If we look at the PhysX Grab component, you'll notice the next field that's called Mesh Tag. This is the tag string name that the PhysX Grab component uses to identify the mesh entity. I'm going to leave the default name Grab Mesh. Let's go back to our Box Mesh entity and add a tag component. Then click this plus icon and type the name Grab Mesh. Now, the PhysX Grab component will know to use this Box Mesh entity for the mesh smoothing. If we go back into play mode, the stutter is gone and the object motion is smoother. One thing to note is that if there's a big discrepancy between the fixed time step and your frame rate, it may still be a little choppy. Now, you can avoid all of this if your fixed time step is equal to or faster than your render frame rate. So if your frame rate is 120, you want to set this to 0.00833333 seconds or lower. However, if your game requires a slower fixed time step for performance, then it might be a good idea to turn on mesh smoothing. If you're using the first-person controller component and you have mesh smoothing enabled, we recommend turning on camera smooth follow in the first-person controller component so that the object and camera are in sync. Now, if we go back to the PhysX Grab component, there's a setting called Grab Response. This is basically the strength of your grab. If you try lowering it, you'll see the object lag behind your movement, while a higher number is quicker and more precise. The next parameter is Grab Enable Toggle. If this is disabled, then you need to hold down the grab key to keep holding the object. Releasing the grab key will drop the object. If you enable this, then simply pressing the grab key once will initiate the grab, and pressing it again will drop the object. Maintain grab is a little different. If this is disabled, when your character quickly turns and the sphere cast no longer intersects with the object, then the object will fall down. When enabled, you will continue to hold the object even with quick turns. Kinematic while held makes the object kinematic while interacting with it. This is useful if you don't want physics forces or collisions applied to your object while grabbing. Disable gravity while held essentially turns gravity off on the object while the object is being held. This is more noticeable if you have the PID held dynamics parameter enabled. Offset grab is a fun parameter that lets you grab any point on the object, offset from the center of mass. This creates a natural and realistic tilt. You'll need to enable PID held dynamics to get the full effect. Disable this if you prefer to use the object's center of mass. This next parameter, title lock, forces the object rotation to always face the grabbing entity. If you turn this off, the object will not rotate and face you. If you are using the first-person controller component with title lock enabled, this will by default only lock the object's yaw rotation to face you. This means you'll still be able to look underneath and above the object, but its yaw rotation will always face you. If you enable this next parameter, full title lock for first-person controller, this will force a full title lock, which means pitch, yaw, and roll rotations will always face you. Angular damping applies a damping to the object's rotation while you're interacting with it. A higher number means slower rotations. This applies to any angular forces that act upon the object in both the hold and rotate states. Linear damping is similar, but only dampens the linear motion. This is most noticeable while the object is moving around, where higher numbers mean slower, more delayed motion. Velocity compensation makes the object match your movement. So if you turn this off and start walking forward, you'll notice the object getting closer to you. Sprinting makes it even closer. If you turn this on, the object stays at the same distance no matter if you walk, sprint, or stand still. Velocity compensation damp rate adjusts how quickly the object's velocity compensation reacts. A lower number means the object takes a bit longer to catch up to your speed, while a higher number means the object reacts very quickly. Now let's take a look at the next section, distance parameters. Min grab distance is the minimum or closest allowable distance when holding the object. It's a good idea to keep this high enough to prevent the object from clipping into the camera. Max grab distance determines the farthest allowable distance when holding the object. Grab distance speed is the rate of how quickly the object moves closer or further away when pressing the grab distance key. In our case, the mouse scroll wheel. The next section, rotate parameters, is all about rotating the object. Freeze character rotation will only show up if you're using the first-person controller component. Enabling this will lock your character rotation while rotating the object, so you can focus on just the object. These three parameters adjust the object's rotation sensitivity for dynamic objects. A higher number means the object will rotate faster, whether it's yaw, pitch, or roll. The next three parameters also adjust the object's rotation sensitivity, but only for kinematic objects. So if your object starts off in a kinematic state, or if you have kinematic while held enabled, this lets you rotate the yaw, pitch, or roll slower or faster. Rotate enable toggle, when turned off, makes it so you have to continue holding the rotate key to rotate the object. Releasing this key will put the object back in the hold state. Enabling this allows you to press the rotate key once to initiate the rotate state, and pressing it again will make you stop rotating. Smooth dynamic rotation basically smooths out the rotations in the rotate state with an exponential decay. This is different from angular damping in that it only applies while rotating in the rotate state. Angular velocity damp rate determines how much smoothing you want. Lower numbers mean more smoothing, while higher numbers mean more precise and discrete rotations. The next section, throw parameters, is all about throwing the object. Throw impulse is the amount of force used when throwing the object. A higher number means farther and faster throws. Enable mass independent throw scales the throw impulse for all objects, regardless of mass, so that the distance thrown is the same for both heavy and light objects. Throw state max time is a cooldown after throwing an object that determines how long you need to wait before grabbing again. This basically prevents you from grabbing the object again mid-air after throwing it forward. Enable chargeable throw turns on the ability to charge up your throws for more force by holding and releasing the throw key. Enable charge while rotating lets you also charge your throw while in the rotate state. Min throw impulse is the lowest or base strength of your throw. Max throw impulse is the fully powered throw strength after a full charge. Charge time is the total time you have to wait to reach the max throw impulse. Now for the fun part, the advanced parameters, starting with advanced hold dynamics. PID held dynamics enables the PID controller when holding dynamic objects. PID stands for proportional, integral, and derivative. A PID controller is a feedback loop that uses these three terms together to determine how to adjust the object's position based on the error. The error being the difference between where the object is and where it should be. In this case, turning this on replaces the simple velocity-based object motion with the PID controller, which creates a lively, spring-like behavior, which can be fine-tuned with the PID parameters. Mass-independent PID scales the grabbing forces so that picking up heavy objects or light objects feels the same. Turning this off will make picking up heavy objects feel more difficult and less stable. Held PID P gain is the proportional gain for holding objects. This controls how strongly the object is pulled towards you, like a spring. Higher values make it snap to your movement faster, but if you go too high, it can overshoot and oscillate like a rubber band. The held I gain is the integral gain for holding objects. This type of gain is less commonly used in PID controllers, but it can be helpful for dealing with bias or steady-state errors like gravity. I'm leaving this at 0 in this example because the proportional gain is already strong enough to overcome gravity. The held PID D gain is the derivative gain when holding objects. This parameter acts like a dampener and helps counteract the proportional forces. Increasing this number can help reduce oscillations, but can also lead to stiff motion. Held PID integral limit caps integral buildup to prevent overshoot. For example, if we set a high integral gain like 50 and the object collides with a static wall and gets stuck, the integral term will build up to a really high value from accumulated error. Once the object is released, the object will fly off due to overshooting. This parameter caps that value so it doesn't build up to a crazy high number. Held PID derivative filter alpha reduces high-frequency noise in the derivative term of a PID controller. Since the derivative term calculates the error's rate of change, it can amplify noise from input jitter, collisions, or camera shake, and other micro-stuttering. This parameter smooths that effect. A value of 1 applies no filtering, while 0 disables the derivative. I like to use a small filter, between 0.7 to 0.9. And finally, the last section, Advanced Title Lock Dynamics. Similar to the previous section, PID Title Lock Dynamics also uses a PID controller, but this time for the title lock. Turning this on creates a spring-like rotation as the object turns to face you. Mass-independent title lock scales the PID by the object's mass for uniform rotations. For example, if you disable this, heavier objects will rotate slower and may have more exaggerated oscillations. Scale-independent title lock scales the PID by size. When this is disabled, larger objects will have slower and more exaggerated title lock rotations. Title lock PID P gain is the proportional gain for title lock. Higher numbers mean the object will rotate faster toward you, but can also result in more oscillations. Title lock PID I gain is the integral gain for title lock. Similar to the held integral gain, this fixes persistent steady-state errors, but for rotations, countering something like wind applying a constant angular force. Title lock PID D gain is the derivative gain for title lock. This adds rotational damping and helps counter the proportional gain. Higher values result in less wobble, but also a slower response and can feel stiff. Title lock PID integral limit limits integral buildup for stability. Similar to the held PID example, if we set the integral gain to a high value and then force the object to get stuck and unable to rotate, then the integral term will accumulate to a really high value and eventually spin out of control when released. So it's a good idea to set a cap here. The TitleLock PID derivative filter alpha, like the held version, filters derivative noise, but for the TitleLock. I like to keep this between 0.7 and 0.9. And we're finally done with the PhysX grab parameters. Now you're an expert if you've made it this far. Try this gem out in your project and build some immersive physics-based games. If you want to go deeper, this gem also includes many script canvas nodes and Lua methods for scripting. We also welcome any contributions and pull requests on the Git repository to improve this gem. Feel free to ask any questions about this gem in the comments section or in the O3DE Discord server.